BioRoof, Conserving Energy and What is to Take for Our Tomorrow by
McKinley Nile
Amaya Paulsen,
Devon May,
and Leah Calvin, and we're from the Fort Concho 3rd grade. Global problem. According to the BBC, a shortage of water is becoming a major global problem. In addition, there is a coming of an era of expensive energy that will be very difficult for everyone on Earth.
Research question. Will a BioRoof and a zero roof conserve more energy and water than a regular shingled roof?
Research. In 2030, half of the world's population could or will be living in areas of high water stress, where there isn't enough water to go around. In other words, our natural resources of water are no longer enough to suit us.
Research. Our planet does contain over 1 billion trillion liters of water, but very little of that is not salt water. Over 97% of the water is salt water. Of the fresh water that remains, over 2/3 is locked away in ice caps and glaciers. Most of the rest is trapped in soil or underground aquifers. That leaves a tiny fraction available for us to use.
Research. 1,000 gallons of water can roll off a typical rooftop in one rainstorm. We waste a lot of water letting that water roll down a sloped roof. 1 inch of rainfall can drop 623 gallons of water onto a 1,000 square foot home.
San Angelo's record low temperature is -4 degrees in December 1989. San Angelo's record high temperature is 111 degrees. In 1 year, an average household spends about $2,200 on their energy. 30% of the amount is spent on heating, while 17% is spent on cooling. In 1 month, a normal-sized house spends $107.29 on their energy bill.
25% of heating is lost through the average-sized roof and poorly insulated attics. 6% of a family's budget is used on heating and cooling.
Interview with Mr. Compas. Mr. Compas from the water department came to our class. He catches 40,000 gallons of rainwater each year. He has a metal roof to harvest cleaner rainwater. All he uses in his house is rainwater. First, he collects several gallons in a separate tank to clean out the roof before collecting water in tanks he uses. You can collect rainwater with a tarp. A 200 square foot tarp will catch 120 gallons in a 1 inch rainfall. Rainwater collected on a clean surface does not need to be cleaned or filtered. Hypothesis. Is it possible to build a BioRoof and a zero roof that both conserve more energy and water than a traditional wood shingle roof?
Plan of action. We are going to build 2 models, one of a BioRoof and one of a zero roof, both made of natural materials. We are going to use a heat lamp and a cooler to test the ability to maintain temperature inside the cooler, simulating a house. We are going to pour water onto the roofs approximately 1 inch and see how much water was captured.
What is a BioRoof? A BioRoof is a flat roof that is made of multiple layers and natural materials. The top layer is grass. The second layer is coconut filler over paper towels, a cookie sheet, and a grate. The combination of grass and coconut provides excellent insulation. Rain will flow into a collecting compartment and drain by gravity through a filter into a collecting tank. The grass will filter large debris out of the water, and the coconut filler will filter smaller particles like bits of leaves and small bugs. Finally, traveling through the paper towels will filter it further.
What is a zero roof? A zero roof is a roof that is made of natural materials. The first layer is gravel, the second layer is sand, the third layer is paper towels, and the fourth layer is screen. The last layer is a cookie sheet. The cookie sheet will support the rest of the materials and maybe even filter it further.
Experiment. The 2 model roofs were built, one using a combination of sand and gravel, and one using sod and coconut filler. A heat lamp and cooler were used to test the ability of the roof to maintain the temperature inside the cooler, simulating house. A second experiment was performed pouring approximately 1 inch of water on the roof and collected to see what percentage of the water was captured.
Energy data analysis. As you can see, the no roof and the regular roof increase temperature, and the BioRoof and the zero roof maintain their temperature.
Results. The heat lamp heated the air to 116 degrees Fahrenheit, with the roof temperature inside the will increase 21 degrees in 1 hour to 91 degrees Fahrenheit. The zero roof will increase by 2 degrees in 1 hour. The BioRoof will increase by 1. Both roofs showed significant insulation abilities.
Rainwater data analysis. As you can see, the BioRoof did the best.
The average roof collection system will collect 65% of the rainwater that falls on the roof. The BioRoof collected 87% and the zero roof collected 75%.
Conclusion. Our hypothesis was proved correct because both the BioRoof and the zero roof provided significantly better insulation and water collection than a standard shingle and wood roof. 2. Both roofs provide a viable alternative while utilizing more natural and renewable alternatives.
Bibliography. This is where we got our information and research.
Any questions?